Look at this equation. It has x squared, numbers, and brackets. It might look complicated, but here's the secret. A quadratic equation is really asking us one simple question. What value of x makes this equation true? That's the mystery we're going to solve. We'll start with a real-life problem and turn it into a quadratic equation. Then we'll understand what a root really means. Next, we'll learn how to find roots using factorization. And if factorization gets difficult, we'll use the quadratic formula. Finally, we'll learn about the discriminant, a quick way to tell what kind of roots an equation has. Let's start with a real problem. A charity trust wants to build a rectangular prayer hall with an area of 300 square meters. The length is 1 meter more than twice the breadth. We don't know the breadth, so let's call the breadth x meters. If the breadth is x, twice the breadth is 2x, and the length is 1 meter more than that, so the length is 2x plus 1. We know the area is 300. And for a rectangle, the area equals length times breadth. So 2x plus 1 times x equals 300. Multiply 2 squared plus x equals 3. Move 3 to the left. 2x squared plus x minus 300 equals 0. And there it is. We have created a quadratic equation from a real-life problem. Look at these equations. What's common? They all have x squared. More precisely, x squared is the highest power of x. A quadratic equation can be written in this form: x squared plus bx plus c equals 0. Here, a, b, and c are numbers. There is just one rule. A is not 0. Because if a were 0, the x squared would disappear. And then it wouldn't be quadratic anymore. Quick check. Which one is quadratic, A or B? Look for x squared, A, because it contains x squared. Now let's look at an NCERT example. John and Giovanni together have 45 marbles. Both lose 5 marbles. After that, the product of the marbles they have is 124. We are not solving the equation yet. First, we're learning how to turn the story into mathematics. Let's say John originally has x marbles. Together they have 45. So Giovanni must have 45 minus x marbles. They both lose 5. John now has x minus 5 marbles. Giovanni now has 45 minus x minus 5 equals 40 minus x. Now look at the word product. Product simply means multiply. So x minus 5 times 40 minus x equals 124. That's our equation. Now simplify it step by step. Expand the brackets, combine like terms, bring everything to one side. Finally, x squared minus 45x plus 324 equals 0. We have another quadratic equation. Here's something important. A quadratic equation doesn't always look like x squared plus bx plus c equals 0 straight away. Sometimes we have to simplify it first. Expand x minus 2 whole squared equals x squared minus 4x plus 4. So x squared minus 4x plus 5 equals 2x minus 3. Bring everything to one side. X squared minus 6x plus 8 equals 0. Now we can see it clearly. Yes, it's quadratic. Now look at this one. It has x squared on both sides. Is it quadratic? Not so fast. Simplify first. The x squares cancel. We are left with x plus 12 equals 0. There is no x squared, so it is not a quadratic equation. Remember, simplify first, then decide. Now we have a quadratic equation, but what are we actually trying to find? We want the value or values of x that make the equation true. Let's try x equals 1. Put 1 wherever we see x. we get 2 times 1 squared minus 3 times 1 plus 1, which becomes 2 minus 3 plus 1 equals 0. It works! So 1 is a root of the equation. That's all a root means. A root is simply a value of x that makes the equation true. Here's an even simpler example. X plus 5 equals 0. Which number makes it true? Minus 5. Because minus 5 plus 5 equals 0. So minus 5 is the root. You may also hear the words solution and 0. Don't let the different names confuse you. For the corresponding polynomial and equation, these are the same values of x. In this chapter, roots of the equation are the same as the zeros of the corresponding polynomial. The important idea is simply find the value of x that makes the expression 0. We now know what a root is, but we don't want to keep guessing numbers. So how can we find the roots more systematically? What if we could break the quadratic into 2 simpler pieces? Look, 2x squared minus 3x plus 1 can be written as 2x minus 1 times x minus 1. Now look at what happened. We have 2 things multiplied together, and their product is 0. That is useful because of one very important rule. If 2 things multiply to give 0, at least one of them must be 0. For example, 5 times 0 equals 0. 0 times 100 equals 0. So if a times b equals 0, then a equals 0, or b equals 0. Let's solve one. We have 2x squared minus 5x plus 3 equals 0. Our goal is to factorize it. Multiply the first number and the last number. 2 times 3 equals 6. Now we need 2 numbers that multiply to 6 and add to minus 5. Those numbers are minus 2 and minus 3. So we can split minus 5x into minus 2x minus 3x, giving 2x squared minus 2x minus 3x plus 3. Group the first 2 terms, 2x times x minus 1, and the last 2, minus 3 times x minus 1. Both have x minus 1. So 2x minus 3 times x minus 1. Now our rule tells us either 2x minus 3 equals 0 or x minus 1 equals 0. Solve both. From the first, x equals 3 halves. From the second, x equals 1. So the roots are x equals 1 and 3 halves. So our factorization recipe is split, factorize, set each factor to 0, and solve. So we get 2 mathematical answers. X equals minus 12.5 and x equals 12. But remember what x means. It is the breadth of the hall. A breadth cannot be negative. So the answer that makes sense is x equals 12. The breadth is 12 meters. The length is 2 times 12 plus 1 equals 25. So our prayer hall is 25 meters long and 12 meters wide. Problem solved. For example, if 3x squared plus 5x minus 2 equals 0, then a equals 3, b equals 5, and c equals minus 2. That's the first step whenever we use the formula. If d is positive, the square root is a positive real number. The plus and minus give different answers, so we get 2 different real roots. If d equals 0, the square root is 0. Plus 0 and minus 0 are the same, so we get 2 equal real roots. If d is negative, we'd need the square root of a negative number. That isn't a real number, so there are no real roots. So remember, positive, 2 different, 0, 2 equal. Negative, no real roots. Let's put the whole idea together. We can start with a real-life problem. That problem can give us a quadratic equation. Then we ask, which values of x make the equation true? Those values are the roots. We can find them using factorization or the quadratic formula. And the discriminant tells us what kind of real roots we have. Okay, your turn. Don't look at the answer. For x squared minus 5x plus 6 equals 0, find the discriminant. Pause the video, give it a try. The answer is d equals 1. That's positive. So this equation has two different real roots.